Today we began to explore another way to display data. This type of graph is called a box plot. Think about all you know about graphing and the different kinds of graphs you've made, and sketch what you think a box plot might look like on your whiteboard. A box plot is also sometimes known as a box and whisker plot. I know it's kind of a funny name. When we think of whiskers, we think of cats, but this type of graph actually has some whiskers on it. Now, what is a box plot? Let's see if you're on the right path. A box plot is a graph that displays data along a number line. So if your sketch used a number line, you're kind of on the right path. Now, what the box plot does differently than all other graphs is uses values called quartiles, which means we have to split that data up into 4 equally sized groups in order to build a box plot. All right, here's the reveal. What does a box plot or box and whisker plot look like? Voila, there it is. Kind of a strange looking graph, isn't it? But as you can see, the box is quite obvious where it gets its name from, and the whiskers are the left and right sides that stretch out from that box. Now, if we investigate this, how are they built? What are the pieces of data that we need to build a box plot? Well, the good news is they are built out of a 5-number summary. And if you think of a summary, it's a short, detailed explanation of something. And so in math, that means we summarize things with numbers instead of words. So the first number we need to help build a box plot, or is shown to us on a box plot, is the minimum value, or sometimes known as the lower extreme. I think everybody in this room can find the minimum value. Minimum is another word for smallest or lowest. We also need something called the lower quartile of the data. We'll explore how to find this a little bit later. But I'm telling you, it's staring at you on that box plot up there right now. The third number we need should sound very familiar to you because we've calculated it before. It's a median. We know how to find median. What are the steps to finding the median? Remember, we got to order that data from least to greatest. Cross them out till we find that number in the middle. Good news, we're good at medians. The next number we need is called the upper quartile. We'll explore how to find this later, but it's also shown to you on the box plot at the top of the screen. And the fifth value, remember it's a 5-number summary, is called the maximum value or the upper extreme. Maximum is another word for highest. So we need these 5 numbers. Now let's take our best guess at what they might be if we look at that box plot at the top of the screen about the number of eggs laid by our chickens today. So if you had to take a guess at which one of those numbers is the minimum value, take a shot, write it down on your whiteboard. If you identified 2 eggs, you are correct. The minimum value is located at the end of the whisker on the left side of the box plot. What do you think the median is on this box plot? It's staring at you. What do you think it is? Well, if you said 6, you are correct. The median is represented by the line that's inside of the box plot. Let's go with the other one called the maximum value. What do you think the maximum number of eggs laid by our chickens is? Well, if you identified 10 eggs, you are correct. 10, the right side of our whisker, is the maximum or highest number of eggs laid by our chicken. Now we're down to 2 values left. One is the lower quartile and the other is the upper quartile. Let's start with the lower quartile. What do you think the lower quartile value is if you look at that box plot? If you identified 3 eggs, you are correct. That is the lower quartile. And what is left to be our upper quartile? Well, if you identified 8 eggs, you are correct. That is our upper quartile. And those are the values we need to build a box plot. What is a box plot good for? A box plot is a clear display of variability, even more specifically than our range. we can see if that data is really spread out or is it close together. If you took a look at our data on this box plot, would you predict that we have a lot of variability or not a lot of variability? Well, one way to tell is by how long the whiskers are. Are the whiskers really short or are they super long? As you can see, they're kind of short, which means we do not have a lot of variability. What else can we tell from a box and whisker plot? Well, there's certain characteristics. One, they can be used to graph large and small amounts of data. Take a moment to think about what type of data are we able to display with a box plot. Remember, we know two different types of data. Which one is it? If you said numerical data, you are correct. We can only graph numerical data. Think about it. Can we find a median if we have categories like your favorite color? Not a chance. The next thing we can do with a box plot is use medians. We will actually use a median 3 different times to find our values to put that box plot together. Just like a histogram, only a few pieces of individual pieces of data can be identified, but not all. So we can find some pieces of data, but not all the pieces of data by our summary on a box plot. Let's explore what that means. So remember, the 5 numbers we need: the minimum, the maximum, the median, the lower quartile, and the upper quartile. Quiz time, let's see if you can identify them. Here's another box plot about the pounds of honey collected from different beehives. So let's start with our minimum value. What is the minimum value displayed on this box plot? If you wrote down 52 pounds, you are correct. What is the median value of the pounds of honey? If you wrote down 56 pounds, you are correct. Let's go for the maximum value. If you wrote down 77 pounds of honey, you are correct. Now those other two values, the lower quartile, 54 pounds is correct. And now last but not least, what is left to be that upper quartile value? If you said 63, you are correct. Now let's look at how these values are found. Obviously we know how to find medians. Obviously we know how to find the upper and lower extremes or the minimum and maximum values, but let's explore how to find those quartiles.